Name is Ayesha, and firstly we will discuss about nuclear weapon. What are nuclear weapon? Nuclear weapons are extremely powerful and destructive weapons that use nuclear reactions to release an enormous amount of energy. They work by initiating a chain reaction of nuclear fission or fusion, which releases a tremendous amount of energy in the form of an explosion. The detonation of a nuclear weapon can cause devastating damage, including the destruction of buildings, infrastructure, and loss of life. Due to their destructive potential, nuclear weapons are highly regulated and their use is subject to the international treaties and agreements. At the center of atom nucleus is present. The nuclear bomb works by fusion by explosion of different chemicals present in it. All modern nuclear weapons are made up of different chemicals which help in the explosion of work by combining chemical explosive, nuclear fission, and nuclear fusion. The explosive compress nuclear material causing fission. The fission releases massive amount of energy in the form of X-ray, which create the high temperature and pressure needed to ignite fusion. All the matter is composed of atoms, incredibly small structures that house different combination of three particles known as proton, neutrons, and electrons. Nuclear energy can be released by two processes, nuclear fission and nuclear fusion. The nucleus of an atom is split into two smaller fragments by a neutron. This is called nuclear fission. And in nuclear fusion, the two smaller atoms are brought together, usually hydrogen or hydrogen isotopes, to make a tritium deuterium atoms. The explosion of nuclear bomb causes the destruction. The explosion occurs due to these reactions, fusion and fission. We will discuss about fusion bomb. Fusion bomb include both fission and fusion reaction. The high temperature and pressure generated by a fission bomb initiate fusion reaction. The process. The primary stage fueled by fission reaction create conditions for the secondary stage where isotopes of hydrogen, deuterium and tritium undergo fusion reaction releasing even greater amount of energy. The greater amount of energy released by the greater reaction. Fusion bombs have typically much greater yields, explosive yields, as compared to fission bombs. Nucleus of fissile atom, it causes the atom to split, releasing a large amount of energy. Chain reaction. The fission process generates additional neutrons, leading to a chain reaction where more and more fissile atoms undergo fission, rapidly releasing a tremendous amount of energy. Explosion. The intense heat and pressure created by the chain reaction result in powerful explosion causing widespread damage. Advanced design may incorporate fusion reaction, thermonuclear reactions to enhance the explosive yield. Control mechanism and precise engineering are crucial to achieving the desired result and avoiding accidental detonation. We'll discuss about fission bombs. The bomb contain fissile materials such as enriched uranium 235 or plutonium 239. When a neutron collides with the nucleus of a fissile atom, it causes the atom to split, releasing a large amount of energy. Chain reaction. The fission process generates additional neutrons, leading to a chain reaction where more and more fissile atoms undergo fission, rapidly releasing a tremendous amount of energy. Explosion. The intense heat and pressure created by the chain reaction result in a powerful explosion causing widespread damage. Advanced design may incorporate fusion reactions, thermonuclear reactions to enhance the explosive yields. Control mechanism. Nuclear reactions are of two types, fission reaction and fusion reaction. Nuclear fission. The nucleus of an atom is split into two smaller fragments by neutron. They involve isotopes of uranium 235, uranium 223, or plutonium. Nuclear fission. Fusion. Two smaller atoms are brought together, usually hydrogen or hydrogen isotopes, deuterium, tritium, to form a large one, helium isotope. This is how the sun produces. Generation by fission reaction refers to the process of producing electricity or the form of energy. One method of power generation is through fission reaction. In a fission reaction, the nucleus of an atom is split into two smaller nuclei, releasing a large amount of energy in the process. This energy is then used to generate electricity. Fission reactions are commonly used in nuclear power plants, uranium 235 or plutonium 239 are often used as fuel in these reactions. When the fuel atoms are bombarded with neutrons, they become unstable and split apart, releasing more neutrons and energy. These released neutrons can then collide with other fuel atoms, leading to a chain reaction. The heat produced by the fission reaction is used to generate steam, which drives a turbine connected to a generator. This generator that converts the mechanical energy into electrical energy, which can be used to power homes, businesses, and industries. Fission reactions are powerful and can generate a large amount of energy, but they also come with challenge such as the safe handling and disposal of nuclear waste, as well as potential risk associated with accidents or misuse. Star fusion. Fusion is a process that powers star, including our very own sun. In fusion reaction, two light atomic nuclei combine to form a heavier nucleus, releasing a tremendous amount of energy in the process. This energy is what makes stars shine so brightly. In the core of star, like our sun, hydrogen atoms are squeezed together under high temperature and pressures. This causes the hydrogen atom to collide and fuse, forming helium. During this fusion process, a tiny fraction of the mass is converted into energy. According to Einstein's famous equation, E is equals to mc squared. The energy released from fusion reaction provide the necessary pressure to balance the inward pull of gravity, keeping the stars stable and shining for billions of years. Stars go through different stages of fusion depending on their masses. Some stars, called red giants, even undergo more complex fusion reaction, fusing heavier elements like carbon and oxygen. Fusion reactions hold great promise for clean and abundant energy. Here on Earth, scientists are working or developing practical ways to achieve controlled fusion reaction similar to what happens in stars. If successful, fusion power could provide a nearly limitless and sustainable source of energy. Topic is gravity in terms of space-time curvature. According to Einstein's theory of general relativity, gravity is not just a force between two objects, but this is a curvature of space and time caused by the presence of mass and energy. Imagine space-time as a fabric, and massive object like planets or stars create a curvature in this fabric. When an object with mass like the Earth is present, the fabric of space-time to curve around it. This curvature creates what we experience as gravity. Other objects like satellites or even smaller objects on Earth will follow the curved path by this curvature. The more massive an object, the greater the curvature it creates, and the stronger the gravitational pull it has. That's why the object with more mass, like Sun, have a stronger gravitational pull than smaller objects like the Moon. This concept of space-time curvature helps us understand how gravity works on a larger scale. Like in the motion of planets and galaxies, it's a mind-blogging idea, but it also makes what makes our universe so fascinating. Einstein theory of relativity explains. One of the key ideas in the special theory of Einstein is that the speed of light is constant for all observers, no matter how fast they are moving relative to the light source. This led to mind bending conclusions such as time dilation, time appearing to pass slower from object in motion, and length contraction, object appearing shorter when they are moving at high speeds. The general theory of relativity, formulated by Einstein in 1915, expanded on the special theory and introduced the concept of gravity as a curvature of space and time. It describes gravity as the result of mass and energy bending the fabric of space-time, causing objects to follow curved path. The general theory of relativity has been incredibly successful in predicting and explaining phenomena like the bending of light and around massive objects, gravitational lensing, and the existence of black holes. The Einstein theory of relativity has had a profound impact on our understanding of the universe and has been confirmed by the multitude experiments and observations. It's a mind-blowing theory that continues to shape our knowledge of the cosmos. Question is, what does it mean to curve the fabric of space-time? Let us take an example. Imagine space-time as a stretchy, flexible fabric that fills the entire universe. This fabric can be thought